Good morning. Your sound's on. Cool.
Do we have anyone?
We've got 4 attendees so far. We'll give it maybe a couple more minutes, so we have a bit more turning up. So the 6 attendees that were there, feel free to post a Q&A. Just to be clear, can everyone hear us loud and clear? Testing live event now. Anyone? Right. Everyone's all shy. Awesome. Thanks, Mike. We've got 9. All right. Awesome. Shall we kick it off?
I think we should kick it off.
Yeah, let's do it. All right. So let me introduce myself. I'm Senior Consultant in Taurus. Hassan?
I'm Hassan Hamid. I'm the Engagement Lead for Cloud Collective.
We'll be taking this this 1.5 hour session to go through a really quick analytics kind of workshop. Let me just quickly share the deck. All right, so we've got a very tight schedule here for 1.5 hours. So we'll take you through a quick deck for about half an hour. And then I'll take a hands-on Synapse demo for about 45 minutes. And we'll leave the last 15 minutes for some open questions and discussions. So I'll hand it over to Hassan.
Yeah, sure. Yeah. So we are here from Antares that has got 3 major practices backed by Microsoft. One of them is modern workplace, data and AI, and application development. So it's a fully certified Microsoft partner in the business for the last 15 years. And we have developed a data governance and a data engagement framework for our clients that I'd like to show in the next slide. So as you can see, these are some of our clients, and 90% of them are with us since more than 3 years. And we work with a range of verticals and industries in health, education, government, public sector. And very recently, at the back of COVID-19, we are developing certain products as well through the Microsoft platform for a few of our clients. If you can move to the next slide, I'd just like to quickly cover what Cloud Collective is. And it's actually 3 leading Microsoft managed partners that complement skills across a wide ecosystem for our clients. And for any engagement that we come across, we make sure that we are covering data and AI, modern workplace, any Azure practice, Microsoft security, or bespoke app development. Now, what I would like to cover in the initial section of this workshop are basically 4 key things. One is the value of analytics. Secondly, the role of the cloud in modern analytics. And thirdly, the paradox many of us face today in our environment when we try to do analytics. And lastly, just a high level on the ideal end state that enables a fluid continuum of analytics for every user, in which we introduce Azure Synapse Analytics. And then I'll pass it on to Kevin to go deeper into the platform. So most of the clients that we have dealt with are very cloud-centric, clearly because the way cloud's enabling companies to start and scale projects today, which is far more easier and faster than they could on-prem, and making it the default environment for new technology initiatives. And what we've uncovered is the ongoing shift to cloud-native applications, including collaboration and file sharing, plus many more, puts even more data within reach for analytics. And the benefits offered by the cloud, as well as its proven security and reliability, has led to a mass migration. And even organizations bound by governance to maintain on-prem data management tend to take a hybrid approach that we have unpacked and use some cloud services in order to take advantage of the cloud wherever they can. And this is the trend that we are seeing at Antares most of the time. Now, the other thing that we like to cover is the cloud-based analytics platforms and the way it eliminates the need for large capital investment. Deploying in the cloud is faster, as I'm sure most of you would have experienced, easier and more flexible than a traditional data solution without the hardware infrastructure costs. Iterating designs and handling diverse data is far more efficient than for on-prem solution, and the cloud makes world-class performance and elastic scaling available at all users. So with this constant information in hand, as the volume and variety of data expands, modern cloud-based data services serve as the home for all data. And in our clients, we've seen workloads of all types, from enterprise models and BI sandboxes to predictions, can be stored, managed, and provisioned all together. And the cloud can efficiently handle different processing schedules without needing someone to manually judge them. And it both delivers enterprise-wide reports and enables ad hoc data discovery through a variety of visualization or data science tools that we'll cover later in this session. This takes me quickly to section 2, which we've called the paradox of analytics. And if you're hearing that there are lots of choices and endless capabilities for analytics in the cloud, you're absolutely right. And if you're wondering if all those choices and capabilities make it hard to know everything you need to know, to do everything you want to know, you're not wrong. So today the industry has evolved analytics to the point of paradox, or so it would seem. And in the next slide, I'd like to explain this. As you can see, take for an instance, the ever-growing volume of data, industry analytics expect it will quadruple between 2020 and 2025. However, if we continue at today's rate, only 27% of that data will be analyzed. So part of the underlying problem has to do with how the industry has approached analytics up to now. For decades, specialized technologies like data warehouse, data lakes that handle specific types of data have helped us collect and analyze data of all sizes and formats. But this has created niches of data, technology, and expertise, which we talk about today as silos. And this has led to the ultimate paradox of analytics, which is the more we apply new tech to integrate and analyze data, the more silos we create. And to harness that power of data, we need to break down silos without creating new ones and approach analytics holistically. On top of the data warehouse or the data lake, organizations needed still more tech for visualization, reporting, data science, and governance. And each new technology we've seen our clients adopt, it creates another siloed operation. And the task of connecting all these systems requires specialized skills, building out protocols and duplicating data, which essentially just creates another world of data set. So when you step back and consider the traditional approach to analytics, building a new system for each new activity made sense at the time. However, as the volume of data and the complexity of the systems continues to increase, adding more and more technologies only compounds the problem. And there comes a point in which the complexity of adding another analytics technology outweighs the benefits of the technology itself. And we've seen this time and time again in our different climate environments. This takes us to section 3 on the analytics continuum, which is a holistic approach, and we believe is the key to unlocking the paradox. Because the goal for modern organizations is simplicity and accessibility across data's growing complexities. As you can see, today it's common for decision makers to increasingly reach beyond traditional reports and dashboards to engage with new sources and tools, such as big data, machine learning, and even AI. However, the more advanced the technology and the more siloed the data and skill sets, the harder it can be for us to understand what the direct implications might be on the larger picture. And that's why we took a new approach to analytics in Azure to enable a more holistic experience of business insights. And we re-architected our operational analytics data stores to take full advantage of a new cloud-native architecture. This fundamental shift, while maintaining consistent tools and languages, is what enables the long-held silos to be eliminated across 3 areas: skills, technology, and data. So decision makers from across the organization are better able to access and understand the insights they need. And this takes me to a very high-level overview of Azure Synapse, which Kelvin will cover in the next section very soon. But what I'd like to share with you is at the core of this Synapse Analytics is a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics into a single service offering unmatched time to insights. With Azure Synapse, organizations can run the full gamut of analytics projects and put data to work much more quickly, productively, and securely. You can generate insights from all data sources. Most importantly, you can combine capabilities spanning the needs of data engineering, machine learning, and BI without creating silos in processes and tools. We have a range of customer examples such as Walgreens, Mindtra, and P&G who have actually achieved tremendous success with Azure Synapse. And now we move to the global general availability. So every customer can now get access to it. So with this, I'd like to hand over to Kelvin to take a much deeper dive into the.
Awesome. Thanks, Hassan. Up until now, we've talked about the value of analytics, the role of cloud and modern analytics, the paradox of many of us face today in our environments when we try to do analytics, and the ideal state is that it enables us a fluid continuum and analytics for every user in which we introduce Synapse Analytics. Now we're going to drill into Synapse to describe a bit about how it works and gives you some tips on how it can be used to optimize your analytics. Azure Synapse provides a unified experience that brings together data ingestion, big data analytics, and data warehousing at cloud scale. Instead of stitching multitudes of services together or creating siloed point solution for just one of these 3 areas, Azure Synapse unifies your data tasks, and your data teams with limitless analytics service that does it all. It simplifies the monotonous but necessary data chores that every team must do, as securing pipelines, assigning permissions, building firewalls, and so on. With Azure Synapse, all you do is secure your Synapse Studio, and your Azure team can take the rest. Simplified analytics is what you have been asking for, and simplified analytics is what Synapse delivers. Creating an analytics service that unifies these diverse worlds and redefines what capabilities an analytics service must provide is the result of a multi-year project. We set out to re-architect and create the new wave of query processing from modern workloads. As modern workloads require both SQL and Apache Spark, we saw that customers would need a cloud-native analytics service engine that converged big data, data warehousing, so they could use limitless scale or on unstructured, semi-structured, and unstructured data. Given this huge range of functionality available for Azure Synapse, it's nice to have a choice about how you allocate and consume resources well. Today, Synapse offers both serverless and dedicated resource models, giving you more flexibility, a better budget control. If you need predictable performance and cost, you can create dedicated pools to preserve processing power for data stored in SQL tables. If you need to accommodate unplanned or bursty workloads, you can use the always available serverless endpoint. Security and compliance. In the quest to break down silos and empower all users with access to continuum of analytics, the question of governance and security comes on the top. Synapse Analytics changes the role of your IT team plays by providing well-managed tools and services that support effective best practices among business users. One of the ways we do this is by building data protection into the fabric of the service. With Synapse, you get a comprehensive approach to security, from access and authentication to proactive threat protection and compliance. And since it's built in Azure, it means you get the latest updates and features as they roll out. We provide you with managed virtual networks that connect your data pools seamlessly and keep you compliant. This way, your team doesn't have to do the specialized work of setting up and maintaining the network. Integrating data might be the biggest problem when it comes to modern analytics. If different data is different silos, how do you connect them? Synapse employs a hybrid approach to data integration that pulls everything you need at your fingertips to bring together different data sources wherever you prefer to do the coding yourself or do low code or no code interface. You can create schedules or automate event-based triggers that keep your data current. Next, we're going to look at the data warehousing functionality in Synapse that supports your SQL workloads. It used to be that using data warehouse as an enterprise level decision, and it took months or maybe years to get it set up and running just right. And playback period was months or even years, even decades. That's not the case today. Built on fully managed elastic platform of Azure, Synapse provides a totally accessible, ready-to-use solution for any size or level of business. It gives you all the features you need in a single tier and provides elastic compute capabilities that can be optimized for different classes of workloads, which goes a long way to help you control your costs. Speaking of control, Azure Synapse Studio provides a unified workspace for your data prep, data management, data warehousing, big data, and AI tasks. The highly visual code-free interface works for everyone. Data engineers can manage data pipelines. Data administrators can automate query optimization, and data scientists can build proofs of concepts in minutes. Synapse Studio is a web-native experience that everything together in one location. You can do every task you need to build a complete solution. Additionally, Synapse makes it easy to both scale in and scale out your workloads for a better management experience. You can scale in an approach that allows for predictable costs and simple way to allocate resources. And you can scale out by increasing the compute power of clusters, as well as using multiple clusters with auto-scale features. Speaking of enabling scenarios, next we're going to talk about how Synapse makes it possible to perform real-time operational analytics for faster decision-making and improved response time. If you're like other organizations we work with, significant amount of the data you produce and need insights from total resides in your operational databases. Historically, it has been nearly impossible to integrate operational data with analytical streams, requiring complex extract, load, and transform pipelines to connect to the two. We set out to remove this barrier and enable low-cost cloud-native HT/AP implementation with Azure Synapse Link. With Synapse Link finally breaks down the barrier that has long existed between operational and analytic streams. Synapse links your operational databases to Synapse Analytics in Azure, providing the ability to implement insights on your business. As soon as the transaction is recorded in your operational store, that transaction will be available in a columnar format for analytics in mere seconds. It all takes a click of a button and we handle the work for you. No need to manage complex ETL pipelines, worrying about keeping multiple data copies in sync. Instead of understanding what happened yesterday, last week, last month, Synapse Links enables you to understand what's happening now. These uncertain times, making decisions based on now is very critical as business plan for and react to sudden changes. We're introducing Synapse Links in Cosmos DB today. This capability to the other operational data stores such as SQL database, Azure Postgres, MySQL, and MariaDB. Azure Synapse also supports streaming data ingestion from IoT devices without aggregation. That's up to 720 gigabytes of raw data coming in that you can immediately create rich insights with your business data, which previously would have isolated in Data Lake and Data Warehouse respectively. You can manage all of this using T-SQL language. Now your data engineers and data scientists can collaborate seamlessly using code-free and code-first experience and train ML models in Synapse, powered by Azure Machine Learning. Notebooks offer collaborative code authoring experience for complex predictive models. Wherever you're using pre-built models or build your own, automated machine learning takes minutes on Azure Synapse versus days or months. You can iterate over rapidly for greater insights. Notebooks aren't the only place where you can offer the choice in how you build your models. Synapse supports industry standard for data types and languages as shown on the slide here. Of course, all these analytical insights mean nothing unless you can understand them. Azure Synapse automatically takes the next natural step in your analytics journey by natively integrating Azure Machine Learning as well as Power BI. We've already touched on the integration with machine learning, so let's dive into the integration of Power BI and Azure Synapse. You can use Power BI directly through Azure Synapse Studio. The new Power BI Performance Accelerator for Azure Synapse automates the creation and optimization of materialized views, resulting in lightning-fast query performance. This simplifies and heightens collaboration with your data analysts, database administrators, as they now can use the same analytics service for querying data and building viewing dashboards. Power BI and Azure Synapse unlocks big data in a way that would otherwise be impossible. As previously mentioned, it is not uncommon for companies today to have petabytes of data across organization. Analyzing and extracting insights from such massive amounts of data used to take hours, if not days. Not so with Power BI and Azure Synapse Analytics. Using direct query, you can take advantage of Synapse industry-leading performance right from Power BI without limits on concurrency. The new aggregations feature in Power BI boosts performance even further by caching data at the aggregated level, enabling instant response times on petabytes of scale datasets with trillions of rows. If the user happens to drill down on the detailed level, Power BI will submit a direct query as usual, invoking Azure Synapse lightning fast query performance. Up to 14 times faster than other cloud providers, and it's up to 94% cheaper too. So there's a couple of links here to get you started, and there's a lot of great material that Microsoft have published to take you through this journey. And recently they've actually given you the opportunity to take Synapse for a spin with very minimal upfront costs. So feel free to have a look at some of those links. Now, it's greatly appreciated that we could get some feedback from all the participants at the end of the session. It takes us a long way to improve our workshops and etc. Cool. So let's go on for a hands-on lab. So I'll give it a couple of minutes while I prepare my material. Apologies, technical difficulties. Are you able to see my screen?
Let me ask you.
All right, can everyone see my screen?
Yes, they can.
Awesome. So we've got this demo environment that has been set up for us to explore Synapse. So we just can start off with having a look at a resource group which was provisioned and has Synapse provisioned within that resource group. So if we have a look at on Azure portal, we'll have this workspace and relative connectivity and settings available for us. We'll go into a bit of details on the right here in a sec. But as mentioned in the deck, there were two types of endpoints. So there was one dedicated and one is serverless. As mentioned, the dedicated endpoint is one that you officially have like a SQL Server database. A serverless SQL import is one which is, as described, is completely serverless, and this is where you pay per use and per query. And all these are completely transparent to you, and anyone who's kind of used SSMS, you can see that there are two databases here for us to actually look into. So this is a dedicated pool here, and it's just a little bit different in terms of how a data warehouse behaves compared to a SQL database, but it looks very, very similar. We'll go through these in a sec. And so let's have a look at this and open up Azure Synapse Studio. All right, so there's a lot going on here. On the blades on the left, we can see there's data, develop, integrate, monitor, and manage. For some of you, again, dev heads out there who's very familiar with Azure Data Factory, some that starts to look a little very familiar. So I'll kind of go from each tab and kind of explain what those blades facilitates. So here we can see that there are three types of computes that are provisioned. As I mentioned, a SQL pool is a dedicated database, a data warehouse, and the on-demand SQL database is where you provision ad hoc analysis on I guess unstructured and unstructured data, and a Spark pool, which I'll just explain a little bit later. That's for scenarios where you want to use notebooks to write Python or various languages to provision data engineering tasks as well as machine learning tasks. And what we can see here, there's also linked storages here. So a blob storage, a Dalek Gen 2, as well as integration data sets. So this is very classic to Data Factory, which describes the table that you're actually going to provision the data for. So here we can actually browse into predefined data set, and Microsoft has actually provided great data sets across, I guess, Bing searches for COVID-19 and the classic New York taxi data sets, which I will go into a lot of, I guess, in depth for interrogating this data. What I will do is go through that example, and what I'll do from everyone is let's pick one of these and let's kind of interrogate another one of these data sets, which I haven't gone into a lot of detail for, and let's kind of interrogate it and build a rough solution end to end. So looking at the classic New York taxis, so the yellow taxi data set. It's a very classic scenario where they've saved all the taxi trips across New York City, like a passenger pickup, drop off to how much they paid, and the distance, the payment method, and etc. So this is 1.5 billion rows at 50 gigabytes as of 2018. So we can actually add that data set into Synapse just to have a play around with large big data sets. So what I've done is actually preset that here, and there's a sample data set here, which is the New York taxi yellow data set. And what you can see on the right, we can really automate the ingestion of this data very quickly. So we can create a on-the-fly query against that data, and I'll explain what that composition does. We can also create an external table which kind of wraps up all of the complexities, so you can still read off the data as if it were to be so we can automate the creation of a data set, a table, which fundamentally defines the definition, but actually just queries the data as if it were it's saved in storage. So here we're just going to do a quick interrogation of this data. Top 100 rows. The format is stored in Parquet. Parquet is a columnar compressed format, which helps highly optimize the analytics engines to kind of query this data set. So here we'll come across in 11 seconds 100 records, which we can quickly have a look. And again, for anybody who's a bit more techie, we can go grab that query and run that on and execute that on the on-demand database and perform the same analytics for anybody who is, I guess, very comfortable in various toolings. But the beauty behind Synapse is the ability to not worry about having additional tools being installed and etc. So everyone can have a cohesive and collaborative environments to work from. So you know, just running a quick little query. Let's do a quick count of the records, and let's have a run of that, and let's do another query and see. And let's do an aggregation of the data. Say, let's have a look at what's available here. Let's go total amount. Let's go do the sum of total amount. So that's running at the moment. And let's have a look at this example here, where it's creating a meta-like table, which spans over that data set. So what that means for us is, if we have a scenario where high velocity data is coming in, we don't need to actually transform the data at all. So imagine all the operational data stores is effectively spitting out data into a storage path. We can effectively query over it and analyze it without needing to stage the data, transform it, and etc. that we traditionally perform as analytical workloads. So let those run for a moment. Granted, it is 1.5 billion records. It takes about a minute and a half to my last calculation. So let's kind of move on with a couple of other tiers and come back to that. So that's the data side, data blade. We have, from the developer side, we have the ability to write queries as defined here. As I've been running in the background over here. So there's a whole set of ways to develop scripts. Anybody who's comfortable in Python, we can create a notebook which can be defined in various languages. There's a lot of .NET developers, or C# specifically, so their skills in this area is actually a good, I guess, transition from their object-oriented programming and to help ease in the load of data engineering loads, I guess, workloads. So it supports Python, Scala, and Spark SQL. So I'll explain, I guess, Spark in a moment. So Spark is basically a high compute engine, very similar to the data warehouse. But what it does is actually an open source platform which allows various, I guess, language to run and to persist table-like data sets as if they were in databases. But what the beauty behind using notebooks in Python is, then your data engineers and data scientists can come together without actually leaving the another environment. So data flows again is a way for users who aren't familiar with writing code and SQL to actually point and click and run transformations. So this example here where load a customer, load some postcode, then join it together. And then we want to spit the records out as a Parquet file, or even just landed into a data warehouse. So there's a flexibility for users to actually operate in Azure Synapse. And again, security is at the core of Synapse. So a lot of this can be segregated role-based security. And as mentioned, it has a native integration into Power BI. Though it being pretty simplistic, but it means you don't need to go off into Power BI to actually build your reports and provision data sets. So what I have here is, I guess, connected reports, which I've just simply uploaded. And you can see that from Synapse, we can both view the reports, but also be able to author the reports. So then it will be persisted across these workspaces. So there's one workspace and a Synapse demo workspace, and these are the connectors respectively. So let's see that load for a sec. Oh wow, demo gods, come on. That's taking some time. Yeah, so here you go. So you're prompted with the the interface that anybody who's familiar with operating in Power BI, and be able to on the fly amend the data. Amend the report without leaving the tooling. And again, anybody who's familiar with Data Factory, this is very familiar to you. So you can land data, copy data from various data sources, and as mentioned before, you have the ability to enrich the data by using data flow. So we're able to have a nice user interface to help drive that transformation. Without even writing SQL to get to a point. I guess the closest analogy I have is if anyone is familiar with a classic SSIS, this is probably the closest tool that you have to build those type of packages. Yeah. So again, there's a lot of monitoring out of the box, which helps us, diagnose and keep track of what's running and what's completed and what's failed. Again, this is very familiar for anybody who's using Data Factory, pipeline runs, trigger, integration runtimes. So integration runtimes, if anybody's familiar, your data doesn't necessarily need to be in Azure. What you can actually install is a self-hosted integration runtime. So that effectively is a little agent which is installed on your on-premise on some VM or some host, which Data Factory, I guess Synapse will reach into and say, hey, I want to grab customers from your CRM system, and your CRM system is highly locked down and behind your firewall within your network. We're able to tap into that and pull that into Azure, so then you don't need to physically do database mirroring and etc. So then leave Data Factory, or I guess Synapse, to actually do the workloads to uplift on-premise data sources into Azure. So Apache Spark is as mentioned, a way in which we can use high compute workloads to spawn over, I guess, all those data sets which were landed in blob storage or data lake storage, and use in various languages to read over that data set. So again, we can see some data sets, queries that have been run recently. Again, this is great for some of our DBA admins, or I get a very simplistic view here. So here we go. So how I ran the count before? So that took 6 minutes. Not lightning fast, but there must be something going on here. But there you go. There's about 1.5 billion records trawled, and that is just running this query here. And that's still running, unfortunately. Yeah, suspended. Loss. Let's try this again. It's to sum the total amount. Apologies for anybody who's not so techy, but what I'm effectively doing is aggregating over all of those files and getting me the total amount, the total, I guess, total fair amount for what's being recorded. So let's say this could be your sales data. This is a good example where you don't need to do much with the data and being able to trawl over that really quickly. So imagine if your ERP is able to produce CSV, JSON, or whatever. We can simply just read off that data set without actually transferring that data at all. So yeah, continuing back here, debug data flows is just a way for us to kind of interrogate what's happening with those a visualized way to transform data. And again, over here we can provision. We can see you've got the built-in serverless pool, and you can see what's actually running against it at the moment. So you can see kind of what's actually happening. I think the data processed 2.5 gig in the last 15 minutes. So some great analytics to kind of see what's happening with your instance. And over here, the dedicated pool is where, as mentioned, it's more of an area where you're able to persist your facts and dimensions and that you're actually wanting to materialize, summarize, or aggregate, so then it can be very quick. So there's the pools here. So we can provision very quickly the performance level, and it will give you a cost per hour. Again, the dedicated pool can be turned on and off. So it's only an estimation on how much it's actually physically going to cost when it's actually only running. So we have some customers where the data warehouse is actually running in the night, running huge computes, populating Power BI, and then turning back off again. So we're not paying for any usage that is actually not being utilized during the day, where everyone is really looking at Power BI. Or the other example is we can scale up with huge compute and then scale it back down throughout the day, so we can utilize the overnight processing and speed up the processing of jobs. So yeah, and again, that applies very similar to a Spark pool, where we can apply a compute node over a notebook to trawl over the data set. So let's have a look here. Here we go. 2 minutes. That's better than before. So here we go. That's a lot of dollars over the New York Taxi data set. I'll show you an example where I've kind of connected this all up into Power BI, though it isn't the prettiest. So I've got a question. No, you're good. Yeah, cool. Again, there's the Q&A box. Feel free to ping me any questions, and then Hassan can interrupt me at any time. Cool. So where was I? Link services, again, anybody is familiar, we can connect to a variety of live sources. So it's not just Azure-based services, there's a lot of out-of-the-box connectors. So anybody who's got Salesforce, SAP, Oracle, so on and so forth, the connectors are endless. Microsoft are always actively adding new connectors onto this, which makes integrating with external data sources incredibly easy. And getting it into Synapse. Azure Pure View is still I guess it's out of preview now. We touched upon it in the deck, but what it allows us to do is look add all your integration. So let's say you use Synapse to do your data engineering. What it now allows you to do is actually see your complete data lineage end to end. Where is it getting the data from? What transformation is being done? And even to then finding out which report is actually using that data. And that's incredibly powerful, being able to create a data lineage end to end out of the box without you coding it by hand. Again, triggers, we can set up schedules and etc. To fire off certain integrations if you want to materialize or aggregate some data sets. As mentioned before, there's integration runtimes which allows us to provision on-premise versions as well as the cloud-enabled ones. We can provision more, which helps us throw more horsepower at it, so we're not dependent on one node. And again, security is key to making sure that your environment is fully locked down. So again, it uses role-based security, or RBAC security, which is very familiar to the Azure portal. And we can kind of create credentials here to help alleviate the necessity to use hard-coded credentials in code, so we can reuse that. And some of the kind of tech heads out there, source control, really important. This is all can be linked into a Git repository. Azure DevOps is incredibly powerful, which allows you to have all your developers work in one seamless environment and work out a single code base. And imagine if you had, dev, tests, and prod environment. Imagine having your test and prod environments automatically deployed. So back to what I was mentioning over here about creating scripts, creating objects and transformations. We do that once and let, I guess, CI/CD do the heavy lifting and doing deployment without users. I guess your developers spending a lot of time deploying, tediously deploying to various environments. Cool. So so back to the data set here, the New York Taxi example. I'm going to show you a quick example which actually is using a Spark cluster instead. It may be a little bit overwhelming, the difference between a Spark cluster, a dedicated node, and a serverless node. But I'd like to kind of just summarize it as one allows you to interact with it with various languages, which is a Spark cluster. So that's really using all the out-of-the-box languages, Python, Scala, C#, and SQL. Whereas the serverless and the dedicated is more traditional to members who are very familiar with SQL. But also, you don't necessarily need to know Python either for the Spark. You can actually write like T-SQL-like syntax in the Spark cluster as well. So I'm just going to quickly run this little script here, and what that basically does is very similar to what's happening here. We're declaring we want to import this New York Taxi yellow data set and prepare this as a data frame. A data frame is basically an object or a table for anybody who's familiar with, I guess, object orientation, which we can then start to perform a method-like and property-like transformations. So you can bring in a lot more, I guess, members on the greater, development team to start to move from their traditional active into data engineering workloads. And again, Python is I believe the nicest language and evolving language at the moment. So anybody who's really getting their hands around Python is going to have a really easy time working with this data set. So I'm going to select a pool, so Spark pool, and I'm going to run that. So in the beginning, it will take time to just provision the Spark cluster. So let's have a look at this Spark. Let's have a look at it now. So this one here is quite a small job, running 4 cores, $2 an hour kind of thing. And again, we can auto scale and provision really massive computes if you really want to go through a lot of data. Let's wait for that to run. Any questions before I move on? Power BI. Any questions in the box? That's what I'm checking. Not yet. Not yet. Okay, cool. Everyone's shy. All good.
We will open questions in the last 15 minutes.
Yeah. Let's try to open it up as much as possible. Too bad everyone can't speak on it. That's makes it a lot easier for us to create discussion rather than just be a one-sided broadcast. So let's have a look at how we go back to integrating into Power BI. As mentioned before, these two workspaces have been connected prior to the workshop. So what I did earlier was build this kind of simplistic connector to that New York Taxi data set. I'm no UX designer, but I'm interested in the data. So what I've just effectively done here, let's see, make it a little bit bigger. So what I've set up here is a Power BI report, which is actually using the technique direct query. So what this actually does is not save any of this data within Power BI. Whenever a query is I guess a visual is performed, it creates a query which best represents this visualization. So I'll also publish that on Power BI. So what I've effectively done is go get me the sum of the trip distance. I just used the out-of-the-box sum, and go get me the payment types. So as you can see, the data is still fairly dirty. So you can see here, let's drill into it just to kind of highlight the annoyance in the data. And again, this is where your data engineers need to pick up these anomalies and work with and filter some of this out, or at least structure it in a way which is meaningful. So here, payment types, we're expecting, I guess, 0, 1, 2, 3. It's an identifier, and we're just summing it out against these the trip distance. So payment type 1, 2, or 3 has, I guess, is it 1.8 trillion miles? Yeah, that's a lot of taxis going around. So I've actually uploaded that demo into here. That one. Here we go. So I've uploaded that earlier this morning, and I've refreshed it as well. So let's have a look at an example where we go, all right, let's kind of do on-the-fly change, and let's see it reflect in Power BI and vice versa. So again, this will take a little bit longer to run in the beginning because it's actually going off and executing this query as of right now. So this is actually going to Synapse, and then trawling those New York Taxi Parquet files right here and now. So you can see it's still spinning, so it's actually not, it's not completing, because as you can see, some of that data is a little bit dirty. So let's kind of look to find another field which is probably a little bit more meaningful to kind of summarize easily. So let's just drop in this payment type. Come on. There you go. Oh, so it took its time. It took it merry old time because it was trying to run the direct query, which said, "Go get me the full aggregation of trip distance without any other groupings." So I'm going to drop on something else. I mean, this is kind of difficult to illustrate considering we don't have a full data model. But just imagine if we dropped in the vendor in here. So you might have a scenario where you have vendor and their details, where they're located, and there's relative hierarchies in here. But you can see that I'm just going to demo how we can actually make a quick change to the report and see that reflect in Power BI. Let's have a look at here, which was still showing the old, aggregations by payment type. Cool. So let's go back to this little example here. So if anybody's familiar with, I guess another, I wouldn't say competing, but supplementary technology is Databricks. It's Spark. The Spark port is and the technique is very similar to Databricks. So anybody who's familiar with that tooling can actually transition very, very easily into Synapse. So they're probably familiar with what data frames are and etc. and where we can actually display the output. So you can see here, this is very, very similar to me running the query, interrogating the data, but it's in a different light where your data scientists are more familiar with, because they're using open algorithms and libraries to help predict the data and etc. And some pretty simple charting tools which kind of helps visualize the data. So here we go. So we've got, I'm just going to split it by vendor. As you can see, the data is still fairly dirty, right? So the vendor ID is 1 through to 4, and then you've got CMT, DDS, and VTS. So for you data engineers out there, that's very, very classic. I suspect something along the lines of from some date or some year, the vendor ID has changed. So if I dropped in a year in there, well, we can actually slice and dice that and find that out very, very quickly. So what I want to do here is actually just save that, right? And we go back to Power BI here, and let's refresh this report. So again, just imagine it's a nice little pretty report, not as ugly as this, where we don't need to leave Synapse Studio to actually make some quick changes. There you go. So it's ready to go. And again, vice versa, if we make any changes on Power BI, Synapse Studio will take those in. And again, you can inherit and use a data set and create a report off that. So let's go and pretend we're going to create a new report. Create a new report off that data set. And here we go, a complete new instance of Power BI reporting. Let's just save that for kicks. Make this one, and we should see that turn up on our workspaces. There we go. So again, seamless integration between Power BI and Synapse. What else? Show here. Reaching out to everyone else. We've got about 10 minutes. What I wanted to do was, time is flying at the moment. What I wanted to do was quickly do a quick end-to-end demo without this new taxi data, and let's have a quick play around with it. So again, if I'm starting out fresh with using Synapse, we'll go look at linked data, and this storage is Microsoft's own storage. Let's go have a look at the gallery, and let's just pick one and just play around with it straight away, which is completely fresh for us to work with. Use unemployment. Great. Let's have a look. Thanks, Hassan. So what does it say? Local area unemployment statistics. All right. So we've got a value period here. All right, let's play around. Let's pull it in, and let's have interrogating of that. Cool. So that automatically adds a reference to that that data set. This is a blob storage. Again, the data can be highly optimized if it does land into data lake storage Gen 2. It's just because this data set has been provided by Microsoft, so it's just their way in offering like free data sets for everyone to play around with. So the optimization or the compute may not be as fast as storage lake Gen 2, or it's effectively a data lake. So let's have a look at this data. And just for kicks, because I'm a true dev head and enjoy SSMS. Oh, yeah, actually I forgot another demo actually. So let's go back to another one which I forgot to run. So back to where I was explaining an example where there are some developers out there who may not be as competent or I guess comfortable in writing full-on code. Here's an example that was provided to us. So again, it imports the data sets and enriches it. So this will actually store the data on our dedicated pool. So let's just refresh that just to kind of show that there's no data there. I guess no tables there, but that closely resembles that. Let's just run that. Cool. Run that, and then it's do its magic. Let's have a look. So, yeah. I'm not sure what the value actually implies. Do you know, Hassan? Okay, cool. So the first task here was, import some data, land it onto storage, and basically stage it. So let's have a look at what's actually happening here in SQL or SMS. We can also use, let's use the tooling that's available to us. So here we go. It's effectively taking that taking that customer data set, enriching it, and then being able to serve this out to an actual data set. So I guess table persisted in your dedicated pool. So this is our classic example where we are actually persisting the data set for use for reporting or historization. And there's some really good debugging tools. Having a look at what's actually happening end to end for anybody who's not comfortable writing code. You can see where it's at, where it's failed. So that's finished now. And so if I refresh this, we should see a dim customer table being populated for us. And there you go. All right, we've got 5 minutes. Let's have a quick conclusion on just interrogating this data. So what I'm doing here is just getting me the aggregation of the sum of the value. I'm not too sure what that data best represents. It'd be good to actually understand it properly. So it's the local area unemployment statistics program for monthly annual unemployment, employment, and labor force data census regions. Okay. So I suspect that must be a percentage. So you can't really aggregate on a percentage. So 4.7% for that particular period. Let's have a quick quiz at how much data is behind the scenes, actually. Again, what we're running here is queries on the serverless model. So whatever timing this takes is what you pay for. So this is always on and operational. You can't turn this off, but you can turn off the dedicated. So great for ad hoc analysis like we're doing right now. So we've got some data set. What are we going to do with it? Let's just have a play around with it and better understand it. So we can quickly understand it with the serverless model, and then we can start to kind of realize and rationalize what we can do with it afterwards. All right, 12 million records, 12.3 million records, not too bad. So another thing just to kind of point out, the beauty in being able to define, I guess, the folders or the containers, you don't necessarily need to load in all of that data. You can define, and because we can't see it, you can actually define folders or for specific years. So if you wanted to, I guess, interrogate data for a certain year, we can just go to that year. Effectively the same thing as doing this, where year equals 2020, right? Whereas the year could be placed into here, which is 2020. So without doing this, we can explicitly define which folder we want to work with, because we may not want to deal with the whole data set if we're only just wrangling some data and just initially analyzing it. Cool. Any questions that have come in, Hassan?
Not yet.
No? Okay. So it is 11:15. Let's leave it for the next 15 minutes for an open discussion. Anybody want to ping me any questions? Shoot. Let's have a look. Okay, Sean. I'll let you monitor in a sec, and I'll see if I missed anything. Yeah, so my other example I had here was creating an external table on the actual serverless model. So you can see here I've created this definition of a table without defining all that path behind the scenes. So when we set it up, it will tell us at what path we want to look into to create this virtual like table. So you can see here, it's so easy for us to handle data as if it were structured, and it's completely transparent to the user, whether or not they're coming from Power BI, SQL, Data Factory, everything. So you can see that enables us to have a lot of data come in at high velocity without needing to transform it. The classic example, CSV file. You can't get away with CSV files. It'll be here with us forever. Those examples would be easily dropped into a folder. Say SQL Server or SIS packages will then take that data, land it into a table that is structured, and then take that table and then do some sort of transformations. So we can now skip that step, and just to take a step backwards, the ingestion of those CSV files are actually this longest step in getting the data into a data warehouse. Because we've fast-tracked that step, we can interrogate it and summarize it very, very quickly without having that come into the storage. And now the benefit is storage on SQL Server is fairly expensive. So leave it out to cheap storage where it is more cost effective, and save the tables, which make a lot more sense to persist for longevity. New one? Not yet. Nope. All right. 10 minutes to go. Anything else we want to cover, Simon?
So I think we've. I was looking forward to any questions.
Yeah.
But if there are any questions on the materials that I presented,
Yep, sure.
Slide number 17.
17 is a summary.
Yeah, that one. Yeah.
Yeah.
Even if there are any questions around the limitless analytics service that we call, that brings together the data integration or enterprise data warehousing that you have chosen already in your environment, and the big data analytics into a single service, please let us know if you're here.
Yeah, and I from a technical level can take you through some really deep examples, and take some of that kind of technical barriers away from you, and enable you guys to overcome those kind of barriers that we were fundamentally constrained to. The cloud does enable us to really scale at any time, and Synapse does provide that point and click experience where we don't need to go talk to an infrastructure team to provision us new servers. Say there's a new workload and say, hey, I need to do some data science workload. All right, cool. Let's go into here and provision a new Apache Spark pool. Or let's say the marketing team has to have their own instance for any reason. Or HR, for instance, HR is a good example where they need to have their own instance for security reasons. So we can provision those dedicated pools at any time. And back to the fact that it's all coming out of a single environment and allows everyone to collaborate and see your whole analytics solution in one spot, from engineering to ingestion to engineering to data science, and as well as visualization. Cool. I think everyone is content with no messages coming in. We might just conclude it.
Yep.
Yeah.
I think we can conclude. And
it was a pleasure taking you through this, and we'll have a few of these going forward. So if there's anybody who would feel that'd be of any interest, we'll help hold these at least once a month. And trying to pick it up a bit more to help, I guess, promote the ability of Synapse and how we can help facilitate that journey for you. Awesome. It was a pleasure. Thank you all.
thank you, everyone.